The second part of this video tutorial, now we will use linear programming based upon the information which we estimated, which we presented in your part first of the video. Now, how to go about that? So first of all, I'm going to create a cell in which I'll simply call the project completion time. And when project completion time, we're talking about that. So these are basically 15 weeks, right? So I'm not again supposed to write 15. I'm supposed to use max function. So which simply represent that select maximum value between the selected cells. So if we do that, the answer is exactly the same. That is 15 weeks. Now at this point, and I'll highlight these two cells. Now at this point, we got this value. And we're supposed to bring it down, or in other words, crash it, which is the initial project completion time, which is the minimum period of time in which a project can be completed without crashing. Now, in order to know that how much can we bring down this particular project in terms of time, we are supposed to use linear programming. For that, we'll use one of the add-ins in Excel that is called Solver plugin, right? Solver add-in. So we are supposed to click on Solver, and in Solver, you got several information to consider. So the first one, let's reset all. So the first one is this, set objective function. Now, what is our objective function right here? Our objective function right here for this particular linear programming practice is the minimization function of a project duration. Let's call it project duration. And this includes about 8 activities from A till H. So I'll write X1, X2, and up till X8. So we need to minimize the Z value or the Z static value, considering the values of activities from A till H, considering some constraints. What are those constraints? There are about 8 constraints. So what are those constraints if we talk about those? So these constraints are somewhat like this. So for activity A, which I represented right here as X, so that is activity A, and then you got activity B, and we got an activity H, right? So the constraint on activity A is activity A can be only crashed 1 week. That is the crash limit. For the next one, we got 2. For the next one, we got 1. So the constraint equations are represented something like this. So if I represent the first constraint inequality, it would be X1 less than or equal to the crashing period is 1. For the second activity, which is represented as X2, it should be equal to or less than 2 period, and so on and so forth. What about X8? It should be less than or equal to about 1 week, or that is what the crash limit is all about. So this means we are going to apply linear programming model on this particular function to minimize that while considering these constraints. So how can we go about that? So for that, which cell are we basically minimizing in this particular case? We are minimizing this cell. So that would be basically the cell under this set objective. So I'm going to select this up arrow key, and I'm going to select this value right there. This is the cell which we need to minimize. Now, the next one is maximize or minimize. So of course, we are minimizing. So I'll check this one. Now, by changing variable cells, what do we need to select in this particular region, right? So I'll again click this up arrow key, and I'll select all of these highlighted cells like those. So this means these are the cell in which we will get the values of decision variables. So here, when I represent X1, X2 up till X8, these are called decision variables in linear programming. So we need to identify those. So we selected that. Now, what about the constraint? So if I can put each and every constraint from A till H, or X1, X2, X3 separately, or I can present them in a single time, in a single equation. So how to go about that? So I'll click this add. Now, this is a dialog box that considers that constraint. See, this self-reference represents the left-hand side of the constraint, and here we got equality and some other options, and then this one is the right-hand side of a particular constraint. So I'll select this cell reference right here, and in this cell reference, I'll select all of these values, and then the constraint inequality is basically less than or equal to. So this means the value right here should be either equal to or less than this side. What value should I select in this particular dialog box? So I'll once again select the up arrow key, and I'll select all the crash limits right here. Okay, once we did that, we'll select OK. Now, I just noticed that in previous video part first, I was again saying simplex, simplex, simplex. So in this one, we cannot apply simplex algorithm because we used a max function in it. So when we use a max function, then we cannot solve it through a simplex algorithm. We are supposed to go for the GRG nonlinear. So GRG nonlinear is selected. Now, what does this particular check mark mean? This particular check mark mean make unconstrained variable non-negative. What does that mean? So we need to put up a kind of a special restriction, and this is common in all of the linear programming models, that the value right here in x1 place, x2 place, and so on and so forth, they should not be any negative value. So basically on a number line, we are limiting the value of a decision variable only towards the positive side or zero. So we are only considering those values. So in other words, if I put up a constraint on x1 value, it would be like this: x1 value should be greater than or equal to 0. Similarly, for x2, for x3, and for all of those, I am to put this particular constraint. So in linear programming, specifically through solver add-in, you're supposed to just tick that one right there. So that basically represents that non-negativity constraint on this particular linear programming model. Now, the model is ready. All we need to do is click solve. So once we click solve and we click OK, so this means this particular project, based upon their crash limit, can be crashed up till 7 weeks. The initial period, which I'll write it right here, so that was the duration without crashing for that particular project, which was about 15 weeks, right? Which was about 15 weeks. So we can crash this project till 7 weeks. So that's the minimum value possible with which we can crash this particular project right here. Now, let's talk about the cost estimation. So our objective should also be to go for the least amount of crashing with the least amount of cost. So for that, let's talk about some cost figures. So the first one, let's estimate the total normal cost right here. So the total normal cost for the project would mean that we need to add all of the normal costs of the activities. So I'll just put up a function equal to sum, and I'm going to select all of these normal costs right here. And if we press that, so this is about 3,080,000, and these are dollars, right? These represent the normal cost. Now, what about the total crash cost? So the total crash cost would simply mean the periods which are mentioned in front of each activity that should be crashed multiplied with the value of slope. So this means this value is basically, these values are multiplied with those values and then added. So for the first one, we would say simply there for activity A, we got a crashing period, which is 1. So we'll do 1 into 10,000 plus 2 into 20,000 plus, and 1 into 10,000 plus, and so on and so forth. We'll follow that whole procedure till end. So there is a quick way to do that. So I'm simply going to put a function which says equal to sum product. So sum product basically mean that we are multiplying and then adding, right? So if I select those sum product, so this is asking me about the first set of values. So the first set of values will include these particular cells, followed by a comma, and then those cells right here. Okay. So this value particularly represents the total crashing costs of considering all the activities. So in this particular one, the F activity has a crashing of 0. So this is not crashed by algorithm, considering the minimization of the crashing period. Now, what about the total project cost? So if I put a total project cost, so that would be just the addition of the total normal cost plus the total crash cost right here. Now, this is now the total cost, and I'll highlight that and maybe bold it so that that can be basically highlighted. Now let's think in a way. This project initially could be completed in 15 weeks, and this project can be crashed till 7 weeks. But let's suppose you got a suggested completion period of the project, maybe in a project meeting, but that suggested project completion duration or time is not equal to 17. It's slightly above that, but below that original duration. So for instance, what if in a meeting they decide that instead of crashing that till its lowest limit, we need to crash this particular project to 12 weeks? Then considering this context, what would be the cost right here? So we'll again use linear programming model in this particular case. So what would we do? Now our objective is to crash this project, not to 7 weeks, but to 12 weeks, and estimating what would be the cost right there at this particular point. So we'll simply do something like this. We'll again use a solver add-in, but this time we are minimizing cost instead of the project duration. So this means we need to change the set objective cell. So that would be this one right here. And variable cells would remain the same, but we need to put up a special constraint on it. The special constraint would be something like this. We need to select this project completion time, which was while crashing. So I'll just simply add in front of that. That was a duration after crashing. So I'm just going to write right here. The 7 week mean that this is when crashing is considered. When crashing is considered. And similarly, in front of that particular cell, I'll simply write no crashing. No crashing. No crashing was considered. Now, our intended period is this 12. So once again, set objective function, minimization of cost. By changing cell variables, of course, they'll be there. That was our first constraint, that the values right there should be equal to or less than the crash limit. One another constraint which we are adding is this. This cell right here, which is the project completion after crashing, should be either equal to or less than this cell right here, which is the suggested period. So the suggested period is this, our maximum amount of crashing to which we can bring that project in terms of time is 7. So we are putting up an equation that this left-hand side, which is represented by 7 weeks, should be either equal to or less than 12. And we'll let simplex the GRG nonlinear algorithm identify to select a value with which our cost is minimum, since we selected that in the objective cell. So once we do that, we'll simply click add. Now there is one more thing to do. So so that second constraint is added. Now, once the second constraint is added, if we click solve right here, so this will come up with some new values. So see, initial cost was more than that. Now this cost is less, fine, with these combination of crashing periods. But you see, these crashing periods are in decimal. So we are going to put up a constraint where we would ask the algorithm to convert these values into integers, into positive integers. How can we go about this one? So I'll click on solver and I'll add one very special constraint. I would say to the algorithm that convert these values into integers, and I'm going to apply that. But alongside that, since our objective is to minimize that, I need to slightly change this option where it says integer, ignore integer constraint. So if I check this box in, so that would simply mean the negation of that constraint which we were putting in first place. So that itself is okay. Instead of 1, we are supposed to put 0 right here and click OK. So that specific constraint is applied. Now we are going to solve, and you will see these values will be converted into now integers, positive integers in that regard, right? So if we solve that, you see it's estimating, we got an answer, and these crashing periods are converted into now integers, positive integers, and that is the cost, the minimum cost possible when we crash this particular project, which was initially without crashing 15 weeks. The suggested time was about 12 weeks. So if we crash this project to 12 weeks, that is the total project cost.